Hey class, this is Mrs. Norris and we're going to do notes for 6-5. These are still the special parallelograms. So we're still talking about rectangles, rhombuses, and squares. Now we're going to use some of our logic skills and our reasoning skills to figure out what shape we have. So we're going to start by understanding the two theorems that prove rectangle. There's two ways to prove rectangle. You should be filling in your notes page. The first one is if a parallelogram has one right angle. Notice the word one there. You only need one. You don't have to put all four as right angles. You only need one, so a minimum of one, then you have a right angle. Then you have a rectangle. If the diagonals of your parallelogram are congruent, then the parallelogram is a rectangle. Two ways to prove rectangle. Congruent diagonals and one right angle. In order to prove rhombus, which is the other special case we talked about yesterday, you need either one pair of consecutive sides being congruent, in other words, these two right next to each other, or you need the diagonals perpendicular, or you need one diagonal that bisects a pair of opposite angles. All three of these cases, you have a rhombus. So make sure all of the red that you see on the screen you have filled in on your notes. Okay, under the box on the first page of your handout, you'll see a handwritten note that says, if it's both a rectangle and fill in the blank rhombus, if it's both of those, then we have the most special case, which is a square. So let's talk about how the diagonals are so important. There's three things that a parallelogram can be based off what happens to the diagonals. So if the diagonals are congruent, then we have a rectangle. If the diagonals are perpendicular, then the parallelogram's a rhombus, and if it's both of those, you can deduce, since when it's both of these, then it's going to be a square. Okay, the next thing we're going to do is we're going to take a coordinate plane again, and we're going to see if we can use our formulas that we know and prove whether it's a rectangle, a rhombus, or a square. So the first thing we need to do is we need to decide if the diagonals are congruent, and if they're congruent, then obviously we have a rectangle. Then we're going to decide, or do a formula to prove, whether the diagonals are actually perpendicular. We're going to use slope to prove that. What do we use to prove congruent? The answer is distance, or the Pythagorean theorem. So the first thing we're going to do is we're going to go ahead and draw a right triangle relative to BD. In other words, we need to find the distance of this segment, or the length of it. So we can do that by counting blocks down, 1, 2, 3, 4, and across, 1, 2, 3, 4, 5. Those are the legs of the right triangle. We can plug those into the formula, the square root, leg squared plus leg squared. When we do that, we get 4 squared plus 5 squared. 4 squared is 16, 5 squared is 25. They add to 41, so we get the square root of 41. You're not going to get a decimal on these. You can leave it in simplest radical form, because remember, we're comparing. We're comparing this length, BD, to the length of AC. When we go to plug in the legs for the AC, those are the ones for this triangle right here. So we're going to go 1, 2, 3, 4, 5. 1, 2, 3, 4. We get the same numbers. Plugging those in, we get the square root of 41. Okay, let's take a minute now and get back where we were here. And let's try to confirm what we just proved. What did we prove by saying BD, which is the length of this diagonal, being the same as this diagonal mean? Well, it means they're congruent. Therefore, we do have a rectangle. Okay? Now, the other thing we're going to do is we're going to check and see if it's a rhombus, using the diagonals for this too. The diagonals of a rhombus are perpendicular. We can prove that by doing the slope. Remember, slope, is rise over run, and we're going to count again. So we can count from the A to C. We're going to see where we go up or down. So let me back up a little bit. For rise over run for BD, from B to D, we went down 4, so we write -4. These are the red lines. And let me go get that blue line out of the way. And then from there, we went down 4, 1, 2, 3, 4, and we went right 1, 2, 3, 4, 5. So we put that in as our slope. Now we're going to find the slope from A to C. So we start here. We count how far up and right we go. We go up 1, 2, 3, 4, and right 1, 2, 3, 4, 5. So our slope is positive 4/5. Now you may get a little confused at first and think that this is opposite reciprocals, but we didn't flip it this time. Since the only thing we did is change the sign, we're actually going to say that this is not a rhombus. Okay, so I need you to write BD is not perpendicular to AC, therefore the diagonals are not perpendicular and we do not have a rhombus. Since we do not have a rhombus, it's impossible that we have a square. So the answer to this question, use diagonals to determine what shape we have, is that we have a rectangle. Okay, on the back of your handout, you should see some blank spaces where you need to fill things in. I want you to try to do the entire back page. The first thing I want to point out to you is in the first one, we'll do the first one together. These are completely corresponding to the ones on the front, okay? So it says if one angle of a parallelogram is a, and you're going to fill in right angle, that's what the picture's showing, one of the angles is right, then the parallelogram is a, and if you look on the front of your worksheet, the answer is rectangle. Now you should be able to fill in all the blank spots here and at the end of each phrase for the rest of these. You can do it based off the picture and also understanding what excuse me, what you see on the front. You also need to do the bottom. See if you can determine what shape you have. Take a guess whether you have just a parallelogram, a rectangle, a rhombus, or a square. All right, that's it. Have a good night. Make sure you fill these in. That's your homework. See you tomorrow.